Here we are trying to find all the values of x which make the given expression a perfect square, and the logical first step is to express it in completed square form. And so in completed square form, we have x plus 6 all squared minus 36 minus 17. And that is the same as x plus 6 all squared minus 53. And that has to be the same as some integer squared, which I've called n. And now we can rearrange in order to take advantage of the difference of two squares. And so I have x plus 6 all squared minus m squared equals 53, and we can now factorize. And so we have x plus 6 plus m times x plus 6 minus m, and those two numbers multiplied together make 53, and we can now try out all the different pairs. And so the first one is 1 times 53 equals 53, and we can now set up two simultaneous equations. And so x plus 6 plus m equals 1, x plus 6 minus m is 53, and I now produce the solution, so I add them together. And so the first value of x that I produce is 21, and we can now test that. And we can now see that 21 squared plus 12 times 21 minus 17 is 676, and that is equal to 26 squared. So the m in this case would be 26. We could, of course, have discovered that by subtracting those equations. X plus 6 plus m equals 1, x plus 6 minus m equals 53. We subtract the equations and we obtain 2m is equal to minus 52, and so that m equals minus 26. But it doesn't make any difference really to say that m equals 26. And so minus 1 times minus 53 is 53, so we can try these. And so adding those two equations together, I get 2x plus 12 equals minus 54, and so x equals minus 33. And this time I shall substitute in there and discover the value of m. So that minus 36 plus 6 plus m equals minus 1. And so x equals minus 33 and m equals 26. And now we check it. And this once again gives us the number 676, which is 26 squared. And so to give a summary of the results so far, when we do 1 times 53, we get x equals 21 and m equals minus 26. We then square that to get 676. Or when x equals minus 33, m equals 26. So far, the two values of x we've discovered are 21 and minus 33. So this time we put the 53 first and the 1 second and generate our simultaneous equations. So I've generated the simultaneous equations. I now add them together. 2x plus 12 equals 54. Subtract 12, 2x equals 42, and x equals 21, which we have had before. It doesn't really matter what the m is, because we only asked for the values of x which make the expression a perfect square. But m squared in this case will be 676 as it was before, and m will be plus 26. And so this is the last pair that we have to do it with. We're doing 1 times 53 this time. I'm sorry, I made a mistake. I meant to say minus 53 times minus 1, and so I have the two simultaneous equations set up there. I add them together. I get 2x is minus 54 minus 12, which is minus 66, and so x equals minus 33. And so the answers are x equals 21 or x equals minus 33.